everyone, welcome to this session. Our chapter is waves. So we're still discussing about the waves. Today let's move on to this subtopic. We'll be discussing the various behaviors of waves. So see, this behavior of waves, they are just characteristics of the waves. What are the common characteristics or those common behaviors that waves commonly have? We've already seen various types of waves. So let's see these various behaviors of waves. So in this we'll see the characteristics of waves. All waves behave in certain kind of characteristic ways. So all kinds of waves, they just behave in certain kind of characteristic ways. Now they can undergo the following characteristics or behaviors. The first one is refraction. So this is the first characteristic of waves. Then there is refraction, there is diffraction, and then there is interference. So all these four are the main characteristics of waves, or the main behaviors of waves. So we'll be discussing each one of them. So these basic properties, they define specifically the behavior of a wave. Anything that reflects, refracts, diffracts, and interferences is kindly labeled as a wave. So these kinds of behaviors or basic properties are the ones that tell us this kind of thing is labeled a wave. Now let's start with the reflection. So this is our first behavior which we'll be discussing in this session. A reflection, simply this is the change in the direction of a wave front at an interference between two different media, so that the wave front returns into the medium from which it is originated, or from which it is obtained, the origin of it. So reflection is just simply the change in direction of flow of a given wave front at an interference or at a breakthrough between two different media or two different surfaces, so that the wave front just it returns to its medium from which it was originated, or from which it came before. So that's what we call the reflection. Common examples, they include reflection of light, sound, and water waves. So these are the common examples where we can see this behavior of wave, that is reflection. We can see it commonly in a reflection of light, reflection of sound, and the reflection of these various water waves. The laws of reflection. So this reflection has various laws. So these laws will just imply us that this kind of what is happening is what we call the reflection. If the reflecting surface is very smooth, the reflection of light that occurs is called the specular or regular reflection. So we have to know that if the reflection surface that it is causing the reflection to happen, the reflection maybe specifically of light that occurs is what we call regular reflection or specular reflection. The laws of reflection, they include as follows. So we've just seen that common note there. Now let's see the various laws of reflection. The first one, that the incident ray, the reflected ray, and the normal, the reflection surface at the point of the incidence lie in the same plane. So the incident ray, this is like the main like originated ray, that is the original ray of the given wave. Then the reflected ray, this is the ray that has been reflected from the reflecting surface, and the normal, that is just the common point between these two, the incident and the reflected. Now these three, the incident ray, the reflected ray, and the normal, they simply lie in the same plane at the reflecting surface at the point of the incidence. So that's the first law that you have to note it, that all these three lie are in the same plane. Moving on, the second one, the angle which is the incident ray mixed with the normal is just equal to the angle with the reflected ray mixed to the same normal. So the normal just makes up two angles corresponding to the given kind of ray that is passing through. Take an example. When we are talking about the incident ray, when it meets or it just makes with a normal, that kind of angle, that is called the incident angle. so the angle which is the incident ray, it makes with simply this, the normal is equal just to that angle that is formed when the reflected ray makes it the same goes to the same normal. So the reflected ray, the reflected angle is just equal to the incident angle. I hope that's clear. So that's the second law when you're talking about the regular reflection. The third one, that the reflected ray and the incident ray are on the opposite sides of the normal. So that you have to note it. So the reflected ray is simply and the incident ray are just on the opposite sides of the normal. So the incident ray on the other side, and the reflected ray is on the other side. So they're just opposite uh, to the sides of the normal. Now, this is the illustration of the reflection of the waves. So here we have the original wave, that is the incident ray, or we can simply say the incident wave. Then this is the barrier or reflecting surface that all these three, the incident, the normal, and the reflected, they all lie on the same plane. That is the first law. Then the second one, we said that the angle formed by the normal when the original wave, or simply known also as the incident ray, or simply the incident wave, with this angle formed here, this one will be equal to the angle that is formed by the reflected wave with the normal. So that's what it is. And we said that all these three, they just lie on the same plane. That is the common reflecting surface. I hope that's clear. So that is simply the illustration of the reflection of waves. Moving on, let's see the characteristics of reflection of the waves. So here we're going to see the various behaviors of the reflection of the waves. The first one, that it obeys the law of reflection. So the characteristics of a given reflection of a wave must first must obey the law of reflections. The second one is that the wavelength of the reflected ray is just the same as that of the incident waves. So the wavelength, you are talking about the length of the wave of the reflected wave will just be equal to the same that of the incident wave. Then the frequency of the reflected wave is the same as that of the incident wave. Normally, when this occurs, a reflection on the regular surface or just a smooth surface, as we've seen the first note when we were trying to talk about the laws of the reflection of the waves. So the frequency of the reflected waves will just be the same with that of the incident waves. Therefore, the speed of the reflected waves is just the same as that of the incident waves. So these four are just the main characteristics, or some of the characteristics of the reflection of the waves. Now let's see the types of the reflections. So far so far as we've discussed we just saw the regular reflection. So from there you get that that is one of the types of the reflection. So there is this peculiar, or just known as the regular one, whereby the smooth surfaces directly reflected light at the opposite angle. So that's the first type. Then there's the diffused, whereby the rough surfaces, they scatter light in all directions. So this is just the diffused reflection, whereby there is a rough surface that, due to this rough surface, it just scatters specifically about, we're talking about the light waves in all directions. Then there's spread, whereby some surfaces, they have a combination texture and smooth surfaces, whereby we contain this varnish over cotton paper, white label on white bottle. So these are just three of some of the types of the reflection that are out there. These types of reflection of the given waves. Now let's discuss this last part in this video, the lipo tank. What is this lipo tank? A lipo tank, this is the shallow glass tank of water that is used specifically in these schools and colleges, just to demonstrate the basic properties of waves. It is specified in form of the wave tank. So the lipo tank is simply usually illuminated from above so that the light shines through the water. So it's just used to explain or to demonstrate the basic properties of waves. Specifically, we are talking about the light. So the ripple tank is usually illuminated just from the above, whereby so that the light just shines through the water. So we get the structure of it, this ripple tank. So some small ripple tanks, they fit onto the top of the overhead projector. This means they are illuminated from below. The ripple tanks on the water show up as shadows on the screen underneath the tank. All the basic properties of those, including the refraction interference, and the diffraction, they can be demonstrated through the ripple tank. Ripple tanks may be generated by a piece of wood that is suspended above the tank on elastic bands so that it is just touching the surface. Screwed to wood is the motor that has an off-center weight attached to the axle. As the axle rotates, the motor whoops, shaking the wood and generating the impulse. So those are just a few explanation of the ripple tank, and here is how this ripple tank looks like. So the main use of this ripple tank is simply used to demonstrate all the basic properties, all the behaviors of waves. So that's all I have for this session. Thank you for listening, guys. We've talked about the behaviors of waves. We've enlisted all of them, four of them. Then we've started discussing the first one, that is the reflection. We've seen the various laws of reflection, and we've later on discussed the types of reflection. Then we've seen the ripple tank as the basic structure of a thing that is just there just to demonstrate or just help to demonstrate all the properties of the waves. Hope that's all clear, and thank you.